Hello, assalamu alaikum. My name is Nur Uddin Javed. Today I am going to present about my final year project poster, which is about the mobile robot for search and rescue. The abstract of the project is building collapses increases death during the natural and artificial calamities. However, different type of mobile robot for search and rescue missions were built. However, they could not travel through the small path beneath the rumble and locate the humans. This project aim is to construct a search and rescue mission robot with a unique body design to find person trapped in the collapsed building. The robot features thermal, ultrasonic, MP6050 sensor, which is also an inertial sensor, and the camera. Signals from the sensor and the camera footage can be viewed on the PC wirelessly. The mobile robot journey is navigated using an ultrasonic sensor, while the camera observes, analyzes, and displays the way across a disaster zone. MP6050 sensor estimates the robot location. Consequently, a remote control search and rescue mission robot has been developed that can transmit live video, detect humans, and determine the location of the survivors. So the problem statement is finding the survivors and their location is a concern under the debris of the collapsed structure to minimize the rescue mission time and life loss. The problem is how to identify the survivors, and the location of the survivors can be determined quickly from an unknown and unpredictable environment under the rumbles. Therefore, a mobile robot is necessary for efficient and smooth search and rescue operation to locate the survivors using the live transmission and sensor and their position by visual and MPU 6050 sensor. So that the objective of the project is to develop a search and rescue mission mobile robot based on tank track design, to design a integrated vision and sensor system to control the robot and detect survivors, and to develop sensor system to get the location of the robot, to analyze the performance of the mobile robot under deliveries. The development of the project has been done in two parts. The first one is the hardware development, and the second one is the software development. In the hardware development, we have done the block diagram, schematic diagram, and the body design. Here I have shown only the block diagram, where we have three microcontrollers. First one, the Arduino Mega, then the Raspberry Pi, and the Arduino Uno. Arduino Mega is actually control the motors, and the Raspberry Pi actually share the camera views and also the MP6050 data through the Wi-Fi to the console PC, and the Arduino Uno actually helps the system to determine the human being through the ultrasonic sensor and the obstacle through the ultrasonic sensor. And the Arduino Mega and the Arduino Uno actually connected with the Raspberry Pi, and the Raspberry Pi actually is transmitting both the data of the Arduino Mega and the Arduino Uno to the console PC, where actually the operator can see all the data in one screen, and by the radio controller the operator can control the motors. So this is the design which actually has been done through the AutoCAD, where we should have the camera in the front, and on the upside of the camera we have the thermal sensor. In the bottom part we have the ultrasonic sensor. This is the tank track design robot with the minimal size, and in the back side we have also an ultrasonic sensor. So in the software development, we have the robot control, instant video and position tracking, and the human detection, obstacle detection. So in the robot control, we have in the beginning the system actually check whether the system has found a controller or not. Based on the error, actually the system determine the controller found or not. If the controller has found, then there are 4 cases that system actually determine what type of controller has been determined by the system, and whatever the controller has been found, the system then check whether there is any input from the controller or not, and the system constantly checking if the controller is connected or not. If the controller is not connected, it will return back and check for the controller nearby his range. And initially the controller output is 128. All the parameters are 128, which actually indicate the robot should wait the position where it was, and if the motor the input are changes from the controller, the robot will act accordingly, and it will go forward, reverse, right and left until the receiver actually getting the signals. If there is no signal, it will automatically go to the wait here position. And then the stream video and position. Position tracking is about the position tracking by Python. Actually, the system actually loads the location tracking data into the Excel file, and it has been the Excel file actually saves the gyroscope and the accelerometer data in 6 different columns. And about the stream video, actually this since the robot cameras actually mounted upside down, so initially when the system started, it will basically rotate 180 degree of the camera view, and then it actually start to record the set resolution and the format. Then it will start to stream into the specific IP address, which is the Raspberry Pi IP address. So if anyone with the specific IP with that website address, anyone can see the video from anywhere, from any device in the world which have the internet connection. In the meantime, the system actually constantly checking whether if there is any device which actually watching the streaming. If there is no one actually watching the streaming, it will automatically stop the streaming. And then this flowchart is actually for position tracking, animation creation through the MATLAB, where the accelerometer data, gyroscope data, tilt compensation, linear acceleration, linear velocity, and linear position all has been calculated and been plotted in the MATLAB, and also the animation of the robot movement also plotted in the MATLAB. Next, in the human detection obstacle detection, in the human detection obstacle detection, in the beginning of the system, the front sensor and the back sensor actually calculate the distance from the obstacle. Then the thermal sensor actually calculate the ambient and the human temperature sensor, and it also it will print the ambient and human temperature. Then the system will check if the temperature is greater than 31, or in Fahrenheit is greater than 89. If yes, then this human is detected, and if not, the human is not detected. It will print it, and it also print the front and back sensor distance measurement. So the front and the back sensor distance measurement, the back side, especially the back side distance measurement, it will help the operator actually to rotate the mobile robot in the rumbles, because we don't know about the situation under the rumble. So it will help the operator to control the robot, because in the back side we don't have any camera. And here is the specification of the mobile robot, where the size of the mobile robot is 30 centimeter by 32 centimeter by 6 centimeter, and the range of the control in the robot is 32 feet, and it has 4 motors and 3 microcontroller, where it has a dual band Wi-Fi to 2.4 GHz and 5 GHz, and the camera resolution of the mobile robot is 1080p, and it can back up to 1 hour. So in the result, we have all the pictures of the mobile robot. In the first picture, this one is the left front side view, where you can see the camera and the ultrasonic sensor and the thermal sensor in the front side of the mobile robot. And then the second one is the top view. This is the top view of the mobile robot. This one is the right side, and this one is the left side. This is the system. The mobile robot has been implemented with the tank truck design. And this is the output of the mobile robot, where the human and obstacle detection can be seen from one screen, and the streaming video can be seen in one screen, and all the position tracking plot and the animation has been plotted in one screen, where the tilt compensated, linear acceleration, accelerometer, gyroscope data, linear velocity, high pass filter, linear velocity, linear position, high pass, and linear position has been plotted in the MATLAB, which actually help the operator to know about the situation of the mobile robot. And also, and the animation of the mobile robot position has been shown in through the MATLAB of 1031 position data. In conclusion, all the objective of the project has been fulfilled. In conclusion, and also the prototype of the search and rescue mission robot has been successfully developed, and it can be operated remotely, able to move in rumbles. Beside, the live vision system with the Raspberry Pi and the human detection and the obstacle system has successfully built. Furthermore, the location tracking system is also developed to locate the robot. The performance of the robot movement, camera vision, human detection, and the location tracking has been evaluated during the testing.